Hi class, this is a video about the learning target functions. This was our first learning target we took at the beginning of the year. So if you're somebody who knows you want to retake this to increase your grade in this learning target, this is a great video. If you're just reviewing for finals, this is a great video. Make sure you have a piece of paper and a pencil out so you can follow along as we do this practice and you can test your knowledge practicing problems on your own. Let's start with one example problem at the beginning of this test. This problem is asking us to evaluate the output of a function given the input. So if you'll remember the way we read this, function f with an input of x results in that input squared take away 9. That input squared take away 9. So as when we go to solve this, I'll just start off by rewriting function of f with an input of -5 results in that input squared take away 9. Notice I put parentheses around the -5 so that when I enter it in my calculator knows I'm multiplying -5 by itself. The calculator needs to be able to do -5 times -5, and so we tell it to do that by putting it in parentheses. A negative number times a negative number is a positive number, so we have 25 minus 9, and that results in 16. So I'm going to fill in this side of my equation. 16 is my final answer. A function of f with an input of -5 results in an output of 16. Problem B gives you an opportunity to practice this on your own. Evaluate the function of g with an input of 0. So what is the function of g with an input of 0 result in? That's your job. I'll give you a moment here to try that on your own. I would recommend that you pause the video, do the problem, and then we'll check in after you finish the problem so you can check your work. So pause the video now. All right, the function of g with an input of 0, I found resulted in an output of 5. So these are the steps I went through. Feel free to pause the video again and review those steps if you need a moment to do that. Let's move on to the next set of problems. We're still working with the same function as above, but now it's asking us to solve. So whenever a problem's asking us to solve, our final answer should look something like x equals some item, right? We're solving for the actual solution to x. We notice now we have f with an input of x results in a value. F with an input of x results in an output of 0. So now I have my function, a function of f with an input of x results in 0. I can replace my function of f with the actual definition of the function. And now I have something I can actually solve for x. So I'll add 9 to both sides. Simplify that. Take the square root of both sides. And my final answer shows me that x can be equal to plus or minus the square root of 3. Because again, -3 squared would give me 9, positive 3 squared would give me 9. So that's my final solution. The function of f with an input of x results in 0, leads me to conclude that x equals -3 and or positive 3. All right, you have a problem you can try on your own now. Problem D, you're solving again for x when g of x equals 1020. So set up the problem in a similar way that we did for C. Go ahead and solve. Pause the video now and we'll check in a few moments so that you can verify your solution. Okay, my final solution for this problem was x equals 338 1/3. Feel free to pause the video again if you need to take time to review those steps. Okay, we're moving on here. The next problem was for HP when we originally took this test, so let's review it. We're calculating the function of f with an input of the function of g with an input of -2. I know it sounds complicated, but it's actually pretty simple if we take it step by step. So what we're going to do is we're just going to focus on this inside function first, function of g with an input of -2. We know how to do that. It's the same procedure we did up here in problems A and B. So let's pull my pen. So that's all we're going to do first. We take our function 3 input plus 5. We get our output. 3 times -2 is -6 plus 5. And then this gives us -1. So g with an input of -2 is equal to -1. Now what I do is I'm going to replace g with an input of -2 with my output, which is -1, and I'm going to plug that into the function of f. So let me just change my color here. So I'm going to go over here and do this. So now I have f with an input of -1, right, because I'm replacing g with an input of -2 with my output, -1. Is equal to my function for f, right? I put -1 in the parentheses again to make sure I'm thinking clearly about -1 times -1. And I have f with an input of -1 is equal to 8, and that means my final answer here is 8. All right, so that's the procedure for that problem. Over here, again, something slightly different, composition of functions. So we have f of x plus g of x. What I do for this is I'm just going to replace f of x with my function, x squared minus 9, my function definition, add to it the definition for my function g of x, and see if there's any like terms I can combine. And immediately I see that okay, well, -9 and -5 are like terms. So I'll go ahead and combine those. I still have my x squared term. I'm going to move my x term in the middle just to fit with my standard notation. And -9 plus 5 would be -4. And that's it. That's my final answer. None of those other terms combined. That's the simplest I can put this function into. So f of x plus g of x is simply equal to x squared plus 3x minus 4. We're going to move down to part 2 of this assessment. We're evaluating the output. We're evaluating either the input or the output given just the visual representation of the function. So we're looking at this graph here. And again, what we have to remember is in this notation, the input is inside the parenthesis, and it results in the output. Since our input is typically represented by x and our output is typically represented by y, we could also communicate that same idea in this notation. And we just remember that our x is our horizontal axis, our y is our vertical axis. In the first problem, we're given the input of 1. So what I might do is just go ahead and find 1 on the x-axis. And if I draw a dotted line up here, I'm indicating all of the places where x equals 1. So up here, x has a value of 1. Up here, x has a value of 1. Up here, x has a value of 1. So along this green line, x is always equal to 1. Now I can simply find where the dashed green line intersects with my function, which is right here. And at this point, x equals 1, y equals 3. So my output, or my y, has to be 3. In problem C, you can see it looks slightly different. Here, we're given the output, or y. and we're trying to find the x, or the input. So I would go to my table, and I would find where y equaled -1, which was here, and I might draw a dashed line, right? All along this red dashed line, y equals -1. I zoom in on the place where the y equals -1 line intersects with the function, and I find that my point is -1, -1, which means when y equals -1, x, or the input, also equals -1. Try B and D on your own, pause the video, and we'll check back in a moment to make sure to check your work. All right, for B, a function of f with an input of -1 gave me an output of -1. That's the point right here in orange. For D, a function of f with an input of -2 gave me an output of -3, and that's the point right here in green. So again, I'm drawing those dashed lines, zooming in on the place where they intersect, and filling in the output or the input accordingly. All right, on the back of this page, we're looking at determining whether or not things fit our definition, relations fit our definition for a function, given either a table or a visual representation of the function. And I just wanted to write the definition, our working definition of a function. So let me just write it up here. Function, so it is a relation where every input has exactly one output. So as long as you know this definition forwards and backwards, you should be okay on these problems, right? Now we just need to be able to think through this definition in terms of our table and our graphs. So let's look at this table. We have all of these inputs paired with all of these outputs. We see that -2 goes to -4 and to nothing else. -1 goes to 1 to nothing else. 0 goes to 0 and nothing else. 1 goes to 1 and nothing else. 2 goes to 4 and nothing else. So each of our inputs is only paired with one output, and that fits our definition for a function. Each input goes to only one output. And I would circle yes here. Down here with my table, we could think about the vertical line test, which is just to draw several vertical lines and make sure that each vertical line only passes through the function once. So I could zoom in on this. And so you could either do it with your pencil or you could sketch some vertical lines, just kind of visually checking, okay, they only cross through the function one time, right? That means that every input or every x value only corresponds to one output or one y value, right? One x goes to only one y. So I would say yes here, and passes the vertical line test would be a different description you can use. And the vertical line test, again, is just drawing a series of vertical lines, or testing that you can draw as many vertical lines as you want, and each one only passes through the function one time. This last one, I'm going to let you test out on your own. Pause the video, give it a try, define, explain, justify your answer, and we'll check in a couple moments to see if your answer is correct. All right, I got that this was in fact not a function, and it's because of these 2 points. They, when I draw a vertical line, the vertical line passes through 2 points, and that means it is not a function. So output of 3 has, input of 3 has 2 outputs. And that makes it not a function. that wraps up our function learning target. Go ahead and watch the video a second time if you still have